Assalamualaikum and hi everyone. So today I will be presenting about chromatography analysis. Chromatography analysis is an analytical technique used to separate complex mixture of compounds. It was first introduced in early 19th and was initially used to separate colored compounds. This is why it's called chromatography by the 6030. It's become widely used for separating colors compound as well. All chromatography system consists of two phases, a mobile phase and a stationary phase. The mobile phase, which can be a gas or a liquid, carries the sample to the stationary phase, separating a core because differently compound interact differently with the stationary phase and have different solubilities and in the mobile phase. In chromatography analysis, separated compounds are identified by their rotation time. Qualitative analysis is done by comparing the retention time of an unknown sample with known standard, while qualitative analysis is performed by comparing the peak area with the standard peak. Now, the objective of this experiment is first, to determine the retention time of N-butanol and 2-propanol using gas chromatography. Second, to identify the components present in a standard mixtures based on their retention time. Third, to identify the component of components present in an unknown sample by comparing its chromatogram with the standard chromatograms. Finally, to study the effect of column temperature on the retention time and peak resolution.
For our methodology, we use gas chromatography or GC. This diagram shows how the GC system works and the main components involved. First, the carrier gas cylinder supplies the gas that carries the sample through the system. The pressure regulator and flow controller control the gas pressure and flow rate. The sample is then introduced through the injector where it is vaporized before entering the column. The GC column is placed inside the oven, and this is where separation of the sample components occur. The oven controls the temperature to help achieve good separation. After that, the separated compounds are detected by the flame ionization detector or FID. Finally, the data system records the signal and displays it as a chromatogram for analysis. This slide summarizes the name and function of each component in the gas chromatography systems. The carrier gas cylinder supplies the carrier gas that move the sample through the system. The pressure regulator and flow controller ensure that the gas pressure and flow rate are kept stable. The injector is where the sample is introduced and vaporized before entering the column. The GC column, which is placed inside the oven, is responsible for separating the components of the sample. The oven controls the temperature of the column to achieve effective separation. The detector, which is the FID, detects the separated compounds and produces a signal. Lastly, the data system or computer records and displays the chromatogram for further interpretation. Overall, this methodology allows us to separate, detect, and analyze the components that present in the sample accurately.
Now, we go to the result for 2-propanol. 2-propanol was the first compound to show up the chromatogram. This happens because it has a lower boiling point and doesn't interact very strongly with the stationary phase in the column. Because of that, it travels through the column more quickly and eludes early than the other compounds. The peak for 2-propanol was sharp and nicely symmetric, which indicates that the separation worked well. Any small peaks close to it are most likely due to trace impurities or background noise. Next, the result that we got for N-butanol. N-butanol appeared later in the chromatogram because it has a higher boiling point and interacts more strongly with the stationary phase. This caused it to stay longer in the column because like 2-propanol, the peak for N-butanol was sharp and clear, indicating good separation. Any minor peaks are trace impurities. The difference in retention time between 2-propanol and N-butanol matches the principle of gas chromatography, where more volatile compounds elute faster than less volatile ones. Lastly, the result for effect of column temperature on mixture. We also studied how column temperature affects the separation of the mixture. At 70 degrees Celsius, the compounds had the longest retention times and moved slowly through the column. This allows good separation but takes longer. At 100 degrees Celsius, the retention times were shorter and the separation was still good, making it an optimum temperature for both speed and resolution. At 140 degrees Celsius, the compounds elute very quickly with the shortest retention times, but the peaks became closer, reducing resolution. In general, high temperatures shorten retention times, but very high temperatures can make peaks overlap and reduce clarity.
Identification of compound. Today we use gas chromatography to identify and separate compound in our sample. We compare the retention time of the unknown sample with those of the standard compound. The peak that's apparent first was 2-propanol and the peak that's apparent later was N-butanol. This difference happened because 2-propanol has a lower boiling points and interact less strongly with the stationary phase, so it's moves through the column faster. The main peak in the chromatogram were shape and symmetry, which show that the separate was good. Minor peaks were also observed, which indicate small amount of impurity or background signal. Gas chromatography works by spreading compounds based on their volatility and interaction with the stationary phase. Compounds that vaporize easily, like 2-propanol, elute faster, while less probability compound that N-butanol stay longer in the column before eluting. Next, effect of column temperature. We also study how the column temperature affect the result. Increasing the column temperature make compound vaporize faster, so they move through the column more quickly and come out sooner. On another hand, lowering the temperature make the compound stay longer in the column because they interact more with the stationary phase. Lower temperature improve peak resolution, which means the peak are sharper and easy to distinguish. Higher temperature can reduce resolution, causing the peak to become broader or even overlaps. Therefore, it is important to choose the right column temperature to achieve clear separation while keeping the analysis time reasonable.
Alright, for the conclusion, the objective of this experiment was successfully achieved. In this experiment, we were able to determine the retention time of 2-propanol and N-butanol accurately using gas chromatography. By comparing the retention time with non-standards, we could correctly identify the components present in the samples. This method also helped us identify unknown components by comparing them with reference data. We also observed that temperature has an effect on retention time and resolution, which shows the temperature plays an important role in compound separation. Overall, this experiment shows that gas chromatography is an effective and reliable technique for the qualitative analysis of volatile compounds. That's all. Thank you.